Today we're looking at notes B-2 point slope form. So you hear the word slope and all these memories come jogging back through your brain. Rise over run, change in y over change in x, or y2 minus y1 over x2 minus x1. Given the slope-intercept form of a line, you remember that the m, the variable m, represents the slope. And graphically, you remember that a positive slope looks like this or climbs from left to right, and a negative slope looks like this or falls from left to right. So in part 1, we'll be doing some special graphs. We're given x equals 3 and y equals -2 and asked to graph. Okay, so these special cases of lines, one will be vertical, one will be horizontal, but which one is which? Well, let's talk about it. X equals 3. So I crawl over here 1, 2, 3 on the x-axis. And for this one, we draw a vertical line. Okay, think about it graphically. Graphically, every single point on this line, every single coordinate on this line has an x value of 3. All the y values are different, but every single x value is 3 on this line. Okay, on this line, y equals -2, we come down to -2 on the y-axis and we draw a horizontal line. Okay, similarly, every single coordinate or point on this line has a y value of -2. The x values are all the same, or all different, but the y values are all -2. Okay, furthermore, talking about these lines, if you have a difficult time knowing whether to graph a vertical or a horizontal line, this is a little pointer or tip for you. The variable that you see here tells you which axis the graph crosses. Okay, so if it's x equals 3, we cross through the x-axis at 3. If it's y equals -2, we cross through the y-axis at -2. Okay, so that will help if you have trouble with that, hopefully. All right, let's talk about slopes since we're talking about slopes up here. So this line, a vertical line, has an undefined slope. And you may have seen a teacher in the past put a U up against that line, undefined slope. This line has a 0 slope, and you can draw a Z on that line. Also, I think horizontal 0 slope. All right, so that was part 1. Part 2, use the point on the line and the slope of the line to find 3 additional points through which the line passes. Okay, so we're using the point on the line and the slope of the line to find 3 more points through which the line passes. Well, let's think about this. Okay, so our slope is given. Our slope m is 3, or 3 over 1. Recall that slope is change in y over change in x. Okay, change in y over change in x. In this case, our slope is positive, so both the numerator and the denominator are positive. So to get to the next point from this point, we're going to change the y values by +3 and change the x values by +1. So just be careful of your placement here. So the y is 3 and the x is 1. And like I said, they're both positive. This whole slope here is positive. So to get to the next point, I would add 1 to the x and add 3 to the y. And it wants 3 additional points, not just 1, so I need to keep going in that same fashion. So add 1, add 3. Okay, so 9, 4 would be my next point. And then again, add 1, add 3. So 10, 7 would be my next point. All right, let's look at number 4. Okay, so this slope, the thing that's different here, my change in y over change in x, is negative. Okay, the main thing you need to remember with a negative slope is that the negative only goes with one number. Okay, so the negative only goes with either the numerator or the denominator, not both. Okay, so here I'm going to take the negative with my numerator, so I'm going to change my y values by -1 and change my x values by +3. So to get to the next coordinate, I would add 3 to -1, which would be 2, and then subtract 1 from 5, which would be 4. And then keep going in that same fashion. So add 3 here, that would be 5. Subtract 1, that would be 3. And then keep going one more time. Add 3, that would be 8. Subtract 1, that would be 2. Okay, and box your answer. So those are 3 additional points. I should have boxed these here too. Okay, let's look at number 5. So number 5 is a special instance because look at our slope. Our slope is undefined. So when you have a special instance like an undefined slope or a zero slope, you probably just want to draw. Okay, so you have a special one, then just go ahead and draw. So coordinate grid, if I have the coordinate -8, 1, so -1, 2, 3, 4, 5, 6, 7, 8, 1, that's that coordinate there. Okay, an undefined slope is what kind of line? It's an up and down line, a vertical line, so it'll look like this. So I want 3 additional points through which that line passes. Well, what did I say earlier about that line? Every single coordinate on this line has the same x value, in this case the x value of -8. So you can choose any coordinate that has an x value of -8. Doesn't matter what the y value is. If it has the x coordinate -8, then it will fall on this line. So I don't know, -8, 0, -8, 22, -8, -11, any of those would work. Okay, you could be creative on that one, isn't it fun? All right, so let's look at part 3. For part 3, we want you to find the slope and y-intercept, if possible, of the equation of the line, and then describe the graph from left to right. Okay, so to find the slope and y-intercept, let's put this guy in slope-intercept form. So we're going to move over the 7x, which would make it negative, drag down the 6y, the positive 6y, that would become -7x plus 30. To get y completely by itself, divide by 6. Okay, so remember to share the love with both. So you have y equals -7/6x plus 5. Divide both terms by 6. Okay, so now our equation of the line is in slope-intercept form, where the -7/6 is our slope and the 5 is our y-intercept. So I do want you to notice how we're going to write this. We're going to write our slope is change in y over change in x, -7/6, and our y-intercept, I really want you to notice this, we're going to write it as a coordinate, because it's a point. Okay, 0, 5. Also, it wanted us to describe the graph from left to right. This is a negative slope. Remember that a negative slope from left to right is falling or decreasing. So we will say this graph is decreasing. Okay. Make a note to yourself so you don't forget. Notice the notation we used for slope, change in y over change in x. Notice a point. That way you don't forget when you write that y-intercept to write it as a point. We're going to skip this one and we're going to go on to the back. So part 4. Find the point-slope form of the equation of the line passing through the points. Okay, so point-slope form from Algebra 1, you may remember y minus y1 equals m times the quantity x minus x1. That was what you learned in Algebra 1. For pre-cal and calculus, we want you to put the point-slope form in y equals. So we will rewrite this to be y equals m times the quantity x minus x1. And then when you bring that minus y1 over across the equal sign, it'll become plus. All right, so we're going to skip 8 and we're going to go directly to 9. So I want the equation in point-slope form, the new one for calculus, of the line that contains these 2 points. So first I need to find the slope. Okay, so change in y over change in x for these 2 points, change in y over change in x. So it doesn't matter which order you go as long as you follow that order throughout. So what I mean is I'll take this y value and subtract this y value. Okay, so negative 3/5 minus negative 9/5. When you minus a negative, turns positive. Okay, so since I took this guy minus this guy, then I have to go in the same order when I do the x's. So it has to be the negative 1/5 minus 9/10. Okay, so on the numerator here, negative 3/5 plus 9/5, that's easy. They have the fractions have a common denominator, so 6/5, correct? Okay, but here we don't have a common denominator, so if you need to, off to the side. Hopefully you know I need to multiply this by 2, top and bottom, so negative 2 over 10 minus 9 over 10 would be negative 11 over 10. Okay, so and then another fraction rule, you have a fraction divided by a fraction, you keep it, change it, flip it. So keep the first, change the division to multiplication, bring this guy up but flip it. So 10 over 11, and just, I always like to keep the negative on top. Okay, so I flipped it, but I always keep the negative on top. So now multiply across. When I multiply these across, notice the 10 and the 5 will simplify. So both of those are divisible by 5. This becomes 2. This becomes 1. So 6 times negative 2 is negative 12 over 1 times 11 is 11. So negative 12/11 is my slope. Now I need to plug into my point slope form. So I have y equals, m. So y equals m, negative 12 over 11, and then x minus x1, close your parentheses, plus y1. Well, it doesn't matter which point you choose, I generally choose the first. So I'm going to go ahead and stick with that and choose the first. So x minus negative 1/5 would make that a plus 1/5. And then remember at the end here, we just tack on the y value. So in this case, minus 3/5. So I use that first point. And then that's your answer for that one. Okay. All right, so let's look at number 10. So on number 10, same process, change in y over change in x. Okay, so I'll do this one minus this one, so negative 1 minus negative 1. So again, minus a negative turns plus, over, since I started with this one, for the y's I have to start with this one for the x's, so 2 minus 1/3. On top, negative 1 plus 1 is 0. Okay, most of you are probably thinking, oh, you can stop right now. You're going to have 0 over something, and 0 over something is always 0. Hopefully you see that, okay? Well, let's just show this process in case you need to see it. So to get a common denominator here, you would have 6/3 minus 1/3. Okay, and that would be 5/3. So again, sure, when you have a whole number over a fraction, keep it, change it, flip it. But y'all, again, do I really need to go further? You hopefully remember that 0 over anything, as long as it's not 0, is just 0. So our slope is going to be 0. Remember, that's one of our special cases. Slope of 0 and undefined slope are our special cases. So again, you get a special case, I really recommend that you draw it. Alrighty, so we're going to go ahead and draw this picture here. We have the coordinate 2, negative 1. And we have the coordinate 1/3, negative 1. So that's about right there. Okay, this makes sense that this slope is 0 because look at the line that would pass through those 2 points. Doesn't that line have a slope of 0? It produces a horizontal line. So our equation of this line, again, is one of those special cases. In this case, it's y equals, we cut through the y-axis at negative 1. And another reason this should make sense to you is because, look at, notice. Okay, Notice the y values matched. Okay, that's a big indicator. If the y values both match or the x values both match, that's a big indicator that you're going to have a special case, and it's a pretty easy one to draw.